Welcome to Sky Creative Channel. Today, we'll uncover the incredible processes behind 5 heavy-duty manufacturing masterpieces. Get ready to dive into the heart of industrial power. First up, prepare to be amazed by the sheer scale and precision involved in creating giant crankshafts. These aren't just any crankshafts. We're talking about the backbone of massive engines for ships, power plants, and more. And leading the charge is the incredible team at Maschinenfabrik Kessler GmbH. The journey begins with the highest quality steel, often melted and cast right here. Then comes the forging process, where immense hydraulic presses apply thousands of tons of force to shape the glowing hot steel. This isn't just about making it big, it's about refining the grain structure, making the material incredibly strong and durable. It's like giving the steel a super strength workout. Once forged, the real magic of precision manufacturing begins. Kessler employs cutting-edge CNC machining technology. Think of it. Massive turning lathes precisely shave off material, creating the main journals and pins. Then, intricate milling operations carve out the complex counterweights and connecting rod journals. But the ultimate step for surface finish and dimensional accuracy is grinding. They use specialized grinding machines to achieve tolerances down to mere micrometers. That's thinner than a human hair. After machining, heat treatment processes like hardening and tempering are crucial to give the crankshaft its final strength and wear resistance. Every single crankshaft then undergoes rigorous quality inspection, using advanced laser and optical measuring systems to ensure perfection. Finally, dynamic balancing ensures smooth operation. It's a testament to German engineering excellence, combining raw power with surgical precision. From molten metal to a perfectly balanced powerhouse, Kessler shows us how huge engineering challenges are met with unparalleled skill and technological innovation. Now for something truly colossal. Welcome to Zimpelkamp, where they don't just build big, they build beyond imagination. This segment showcases the production and machining of workpieces so large, they dwarf humans standing next to them. Think 200-ton steel plates and press frames used in metal forming, nuclear power, and aerospace. The production involves melting iron at high temperatures, around 1,350 degrees Celsius, and pouring it into molds. For the 320-ton casting, Zimpelkamp used 5 ladles of molten iron. The process requires precise control to ensure uniformity and prevent defects. Given the size and complexity of these castings, hand molding is often employed. Skilled craftsmen use specialized tools to shape sand into the desired mold cavity. Cores, which form the internal cavities of the casting, are also created using similar techniques. The necessary spheroidal graphite cast iron is melted in large furnaces, ensuring precise chemical composition and temperature control. The molten iron is carefully poured into the prepared mold, filling every crevice and ensuring a uniform casting. The casting is allowed to cool gradually under controlled conditions to prevent cracking or distortion. As the iron cools, it solidifies, forming the desired shape with the characteristic spheroidal graphite microstructure. Once solidified, the casting is carefully removed from the mold. Depending on the specific requirements, the casting may undergo machining processes to achieve precise dimensions and tolerances. Rigorous quality control measures are implemented to ensure that the casting meets the specified standards for strength, hardness, and other properties. These large castings are used in heavy machinery and industrial applications, such as the lower press beam for a 12,500-ton closed-die forging press. Such components are critical for industries requiring high-strength and durable materials. Zimpelkamp's achievement of casting a 320-ton component set a world record, showcasing their expertise and capability in handling large-scale projects. Producing castings of this magnitude presents several unique challenges. Maintaining the stability of the large, hand-formed molds during pouring and cooling is crucial. Ensuring consistent temperature control throughout the casting process is essential for achieving the desired material properties. Safely handling and transporting these massive castings requires specialized equipment and expertise. Let's shift gears to high-powered diesel engines built by Wartzilla and precisely machined by Coburg. These engines, used in ships and power stations, demand massive engine blocks milled with surgical precision. Coburg brings in its vertical turning lathes and gantry mills, custom-built for cutting at scale. Imagine a tool the size of a car moving with the accuracy of a Swiss watch. Machining begins with aligning the massive engine block under a traveling column mill. Each cylinder bore is machined to within microns, ensuring perfect compression. Crankcase openings, camshaft bores, and bolt holes are then drilled and tapped using robotic tool changers. With final grinding and quality inspections, these machines ensure that every Wartzilla engine runs like a dream, whether it's sailing across oceans or powering an entire city grid. Now, let's head to Campbelltown, where steel rises to meet the sky. At Wind Towers Scotland Limited, wind turbine towers are crafted with precision and strength to withstand nature's fury. The journey starts with rolling massive steel plates into cylindrical sections using hydraulic bending machines. Each section, known as a can, is then submerged arc welded along its seam, a technique known for deep fusion and minimal defects. These cans are stacked, aligned, and welded into full tower segments, each one weighing tens of tons. Internal platforms, cable ladders, and flanges are installed before grit blasting smooths the surface for corrosion resistance. A final coat of industrial-grade paint seals the deal, preparing these towers for decades of high-altitude performance. And just like that, steel becomes wind-catching architecture. Our final stop takes us to a powerhouse of metal, forming the Acupac BMBB25 flanging machine. This beast of a machine is built to shape flanges on thick metal ends, ideal for pressure vessels, tanks, and wind turbine bases. It begins by gripping a steel disc with hydraulically powered rollers. Then, with controlled force and precision, it gradually bends the edge upward, creating a perfectly curved flange. Thanks to programmable control systems and heavy-duty hydraulic rams, even high-tensile steel is no match. The operator can easily switch between flange diameters, profiles, and material types, making the BMB25 a true multitasker in any heavy fabrication shop. And of course, safety systems and laser alignment tools keep the process accurate and secure, all while reducing the need for post-processing.